show you something about continuous delivery in general. So what is continuous delivery actually? And then we talk about a continuous delivery pipeline. So how we can build a pipeline and how it is constructed. Then we talk a little bit about tools. So there are a lot of tools out there that help us creating a continuous delivery pipeline. And last but not least, we talk about continuous deployment, which is a kind of special continuous delivery or extension of that actually. So why continuous delivery? Nowadays there is always this slogan like time to market is important and time is money. So it's very important that we develop software quite fast and we can deliver software very fast. It's a demand that comes from the market, and it's more and more important also in future to develop software quite fast. So basically continuous delivery focus on optimizing all required steps to create a shippable artifact. That does, in the first step, it does not include the deployment itself, but all the necessary steps to create some kind of artifact that could be deployed. So in other words, continuous delivery focus on things like do things more often. So if you release more often, you get used to it. You can practice releasing, and it lowers your risk when releasing a software. If you simplify things like tests or other stuff, it also reduces your risk. It lowers your risk when you deploy and when you release your software in production systems. And of course, if you have less code changes per release, you also reduce your risk that your release might fail. So those are the main important things on continuous delivery, or continuous delivery focus to improve your releases. So continuous delivery focus on automation of things that could be automated, and this brings us reproducibility. That means if I can automate some step in my continuous delivery pipeline, I have the chance to reproduce all the necessary steps to create identically the same thing. So we talk about this later. It's called idempotent. So you might heard this word already, but it's on the next slide then. Of course, you can simplify the tests. That means I saw a lot of tests that are quite awful, so you might don't change it, and if the test fail, a quick fix is to just add ignore on it, and the test is fixed. Yeah, but test actually should be some kind of documentation of your code. It should be a help for a new developer to understand your code, to read your code, and to verify what actually the test tries to test. And of course, less code changes per release means you have a lower risk. But what means idempotent? It's kind of, this calculation looks good, 1 + 1 is 2, but if we calculate it again, it might be 2.5. So that's not good. And that means idempotent. So you want to do things automatically or not automatically. If you repeat some things, you expect the same result as before. So that is very important for continuous delivery in general, and it is very important for software development if you use automated things like automated builds or automated deployment pipelines. So yeah, 1 + 1 should always be 2. So what are the actual values of continuous delivery? It tries to get some regularity in your process. So if you release quite often, if you release, for example, once a month or once a week, it's better than you release once a year. So get used to the old processes that are involved when releasing new software. Then continuous delivery focus on reducing regression problems. So if you have some kind of feature that breaks sometime in the future, you don't want to have those things breaking again if you fix it. So you want to fix a problem once and then it's fixed for all the time. So that is something that also should be focused when using continuous delivery. And of course, optimization of every required step that is necessary to deploy a software in your production system. So this leads to automation. You can get regularity through automation. For example, if you trigger your builds on every single commit that is done in SVN or Git, you can create a build, your Jenkins fires and builds all your software components. So this is something that you can automate, and this produces artifacts, and this actually produces for you regularity, so get used to it, you get fast feedback. We'll have a look at this a little bit later. And the regression, for example, is very important, that if you fix a problem, you hopefully create a test to ensure that your fix is working. so you reduce the amount of regressions later on. So fast feedback is quite important. We have a look at this also later. And the optimization of every required step brings us time to market. So that means you are faster able to release software if you optimize every single step that is required to release a software. So this is all good. Everybody wants to have a fast continuous delivery pipeline, but there are some common quotes you probably heard of already. Things like, we don't release very often because a release is expensive and risky. Who knows this quote? Okay, there are some people already. Then there are quotes like, we bundle features and bugs instead of releasing them immediately. So who had this situation already? All right. Also a lot of. There is another nice one. Like, our acceptance test takes weeks or months, so yeah, we cannot release immediately. Okay, there are also some people. And things like, for hotfix we skip testing to speed up hotfix releases. Yeah, so skip the test. It's important, go out with this release. You know that already? Yeah, you know that, of course. So continuous delivery is really awesome. It helps us, it fixes problems. Every article about continuous delivery, if you read it, it's awesome, it's cool, you want to have it, you want to use continuous delivery. So it's really cool, and yeah, it solves a lot of problems that we have. But actually, to really use continuous delivery, we need some kind of pipeline system. That means we need an automation that brings us at the end an artifact that could be deployed and invokes all the steps required for continuous delivering pieces and parts of our software components. So a common continuous delivery pipeline looks like this. You have some kind of a commit stage. That means you commit your code with everything that is necessary to commit your code. So you might have a kind of bug tracking tool where you comment your fix or something like that. So you do all the manual stuff and then commit actually your code to some code base like Git or SVN. Afterwards, all your unit tests are fired. So that means all the unit tests testing units only, first of all, are fired. So you want to get a fast feedback out of that. So if the code, for example, does not compile, while compile is a part of commit, you want to get a fast feedback on that. You don't want to hear weeks later that your code does not compile. After the unit tests, you have some kind of acceptance tests normally. Acceptance tests are normally end-to-end tests, or could be, for example, automated tests with Selenium. So you test actually stories, user stories. If you work with sprints and Scrum, you could just test your user stories against a target environment, like a development environment or a staging environment, and you test actually the acceptance criteria for your stories that you want to deploy. After those succeeded, you can go to your QA, to your quality assurance, and ask them to do some explorative testing on your software. So explorative testing normally focus on finding kind of bugs in new features. So you have new features and you want to see if these new features create some impediments with other features, or has some hidden problems that you actually are not part of the acceptance criteria. And if this all succeeds, if everything is okay, then you can deploy your new software. So actually, fast feedback brings us one important thing. If, for example, acceptance test fails, so a user story is not completely implemented, then we want to know about this quite fast. So we don't want to have the acceptance test weeks later, but we want to have it quite fast. So in the case of an acceptance test failing, we actually don't have to invoke the other steps in the deployment pipeline. That means we can skip the explorative testing, and of course we can skip the deployment, because our code is not that what actually is expected from the user story. But why do we need fast feedback? So if we take a scenario with one single developer, and we have some users out there using our software, and we commit some code. So area of this bubble is a commit of our code, and we continuously commit code. We write new features, we commit that to Git, and they are built and they are tested. And then sometime in the future, if the sprint is almost over, we have some kind of acceptance test, and the acceptance test is great, or everything is cool, so we release the new code, we get a new version of our productive system, and afterwards the users are out there using our new software and actually find some bugs, and it's a very inconvenient situation. So there's a lot of time between committing your code and you get the report of a bug in production. So actually the poor single developer creating new software here on the left has now to remember everything that he actually did when writing this feature. So you probably don't remember every aspect of this story, of this user story. You probably forget some concepts you might use during development. So the time between creating code and getting feedback to your code is mostly very long. So the target of continuous delivery is also to reduce this time, to get really fast feedback and to get as soon as possible feedback to your code, because you are fresh into it, you have it in your mind, you created just this feature, so you can remember better how your concepts actually work in the software. And to achieve this, well, there are a lot of tools out there that can help you actually to improve your continuous delivery and find those bugs that might be in production otherwise. But first of all, if you want to use tools, if you want to create a continuous delivery pipeline, we need some automation. And the first part of automation is our build. So hands up, who is exporting WAR files from Eclipse and deploys it to Tomcat? Okay, hopefully not everybody. So someone of you might use Ant, Maven or Gradle. And this is the first step of automation. So you don't export your WAR file or your jar file through an EDA and deploy that in a production system. You actually want to reproduce your builds. That means the main goal should be, if I create some software and build it with Maven on my machine, you also want to create the software with Maven on your machine, and we want to get both the same result. So the build itself should be reproducible. That's what we heard some slides before. So every build with the same version should create the same artifact. Second, if you build something, never use snapshots. Snapshot is a quite bad thing of Maven. It's a cool feature. It was a cool feature, but actually when we use continuous delivery, we don't want to have snapshots. Every build that is triggered should create a new version. So even if it's the same kind of source code that we're building, again, it's a new version. It's a new step that we create in our continuous delivery pipeline. So we need a new version flag on it. So we see here, for example, we build a minor release and it gets a new automated version at the end. So we can do this, for example, with tools that are out there like Jenkins and other stuff. They can automatically create incremental build versions and attach this to your project. So every build exactly should lead exactly to one single version that you can identify. No snapshot means also if you create the same kind of source code again. So you trigger the build, one source code, you trigger the build 2 times, you get 2 different release versions, and you have the identical artifact. I mean, if you create a hash code over it, you might get some changes because in your POM files there are different versions. But otherwise, actually it should be really the identical artifact. The same if you create, for example, another version, like a higher version 1.79, it should also every time create the identical artifact if you create the same source code again. That's very important, that's idempotent, and that is extremely important that you can reproduce things that are happening in your continuous delivery pipeline. So if you created successfully your continuous delivery pipeline with no snapshots, so you created the artifact, it's the first important step of your continuous delivery pipeline, then you want to put this artifact somewhere. So for example, there are products out there like Nexus and Artifactory. So if you finished creating your artifact, your jar file, your versioned WAR file, you want to put it somewhere. And therefore Nexus or Artifactory, both of them, for example, allow rules like you cannot update existing versions of your software. That means if you created a version 1.0 and you want to build again a version 1.0, you get an error because this artifact is already available. That helps you creating single versions with a single versioning of your software. And now there's another tool out there, SonarQube. Who knows that already? SonarQube? Okay, a lot of you guys know that. That's good. And who of you also uses quality gates? Cool, great. More than 3. Well, quality gates are very cool stuff to ensure quality in your software. So if you want to have a code deployed automatically to a production system, you might also want to check your code against some quality measurements. And one of those could be, for example, test coverage. You don't want to release new code that has not, I don't know, 50% test coverage. So things like that could be done with Sonar Cube. So after a successful build, for example, you can trigger a Sonar build and check if your code really fits the requirements. There are other tools out there like checkstyle, PMD, findbugs. All of those actually can create some kind of build breaker, it's called. So if you, for example, invoke your continuous delivery pipeline with Jenkins, you can create with plugins for checkstyle or for Sonar, you can create build breaker that actually break your continuous delivery pipeline. So that, for example, ensures us a minimum amount of quality of our software. And the third thing, now we have testing, we have a versioned artifact. Now we need some kind of infrastructure where we can deploy our software. So infrastructure as a code. You already heard that probably about DevOps and things like that. So the main focus on DevOps, for example, it's also an organizational topic. But in this case, for example, it deals with descriptive infrastructure. That means you want to create some kind of descriptive file that describes your infrastructure. You want to version this kind of file. You want to review this file by another developer. So the basic idea behind those things is that you have one single file. For example, we heard already talks about Docker. So you can create things like versioned infrastructure code with things like Docker or Puppet or Chef, etc. So that is very important because if it's descriptive, you can recreate new environments on demand. It's also more robust because you can create the same environment again and again and again, and it should actually always be the same environment. So there should be no change between environments if you create it 3 times. And of course, if you automate it, if you don't configure your environment manually, you have a higher chance that it lowers your risk. I mean, you know, you have a fixed version of operating system, you have a fixed version of JDK, you have a fixed version of Maven or a database driver. So it's quite convenient that it lowers your risk a lot if you automate those things. So for example, if we have some kind of descriptive code describing our infrastructure, we can build this kind of descriptive code and create a virtual machine image, for example. And this virtual machine image could be used, for example, to deploy some software on it. So we can also use this virtual machine image to deploy it on Amazon Web Services, Heroku, or Cloud Foundry. So we create our environments automatically through a build system and deploy those environments, and they are ready for hosting our applications. That means, for example, we have some single code that describes our virtual machine. We create this virtual machine or these containers, if you use Docker, for example, and we can create a development environment, a staging environment, and a production environment out of the same code. And that gives us the chance to have an environment that is identically between each stage. So we have a development environment, we have a staging environment, and a production environment. It's all the same. So who of you already heard things like, oh, this feature works in development, but not in production? All right, so here you go. This is your solution. You have to try to find a way to get rid of the manual configured virtual machines and the manual configured environments and go to an automated system where you can automatically create your environments. And of course, if you can automate your environments, you could just create environments like this. And for having automated environments on your local machine, there's, for example, a very cool tool called Vagrant, and it creates virtual machines in a descriptive way, like I told you right now. And it could also wrap Docker environments. That means the Docker commands, we saw a talk already about that. You can wrap those Docker commands and create your Vagrant virtual machine. And within this Vagrant virtual machine, you create your Docker container, for example, for having a Postgre database, for hosting a node server, for hosting a Tomcat, etc. And you can put it up, this Vagrant image, locally on your machine, and your complete development environment is up and running. that's extremely cool if you have a team that, for example, uses different laptops. Like the one person is working on Mac, the other one is working on a Windows machine. So in this case, you always have the situation that on the machine of one person it works, and on the machine of another person there are some kind of mysterious things happening, and you spend a lot of time to find those bugs. But actually, it's the same code base, so it's more or less a waste of time. And to get rid of those things, you can automate those things so that everyone is working on the same kind of infrastructure locally in your machine. Docker, for example, uses containers instead of virtual machines, so it's very easy to create those containers. It's very lightweighted, and you can actually Docker also runs on a kind of host or operating system. For example, with Mac and with Windows, it's boot to Docker. And if you use Vagrant, for example, you can create a host operating system with Vagrant, like Ubuntu version, a specific version, so that again, if you have someone working on Ubuntu and another one is working on Mac, and the third developer is working on Windows, you can create identically the same development environment on every machine for the developers, so that you get rid of those things, those mysterious things happening on single development machines. So Docker is a great tool for achieving those things. Then there's another thing called Chef, a pendant to Puppet, and it's a descriptive tool for creating virtual machines and platform configuration. So if you create a development environment or a staging environment, you can use Chef or Puppet to automatically create those environments for you. So have a look at those. I cannot go too much in detail for those features, but all of those tools have a great documentation. So in about 1 or 2 hours, you can create a working example that is quite advanced with every of those tools, like Vagrant and Docker. It's really good written. This documentation is worth a look. So if we put it all together, all those tools for code quality and test automation and stuff like that, so we have a kind of extended continuous delivery pipeline. It starts with the commit. So you commit your code and it's getting built. So we check if it compiles. Afterwards, we run our unit tests. So if they succeed, we have some kind of acceptance tests, like Selenium end-to-end integrations, integration tests, stuff like that. Afterwards, we want to check our code quality automatically with, for example, SonarQube. So we want to check if we have enough test coverage. We want to check if we have not too many violations in our code. And then we put this created artifact with a specific version to a repository. And if it's in a repository, we can start creating our virtual machines, and we can start creating our environments. For example, we want to test it first on some kind of staging environment. So we create our staging environment with Docker and with Chef, for example, and put it somewhere. And then on this environment, we can deploy our application. And if this application is deployed, now we can start explorative testing to get a releasable artifact that is actually also tested from the quality assurance. And then, if the quality assurance is happy with our work, we can deploy this release. So now actually we had continuous delivery. So we did all the necessary steps to create a shippable artifact, but actually deployment is more or less something that has to be done by some specific person. So let's have a look at continuous deployment. What's the difference between continuous delivery and continuous deployment? So we remember this kind of continuous delivery pipeline where you have this explorative testing. And in most cases, this explorative testing is done by several persons, by a QA employee that actually tests our software against specific user stories, and goes into deep and tests different features and tries to find problems that are not so obvious. Well, the first approach to create continuous deployment is to skip the explorative testing. I mean, if you're quite happy with your processes, and if you have enough self-esteem as a team that you can actually create quite good quality with your software, and you have a lot of testing, automated testing in your software, it could be a cultural thing that you say, well, we skip the explorative testing because our test coverage is about 60-70%, so we don't need it. Of course, you can replace the explorative testing with some kind of behavior-driven development tools. For example, JBehave is something like that. It's a very good connects between the quality assurance or the business guys and the development, because it breaks the ice and creates a nice bridge between them, so they talk about the same acceptance criteria. It's a really cool tool. You should have a look on it, and it could automatically do our acceptance tests in this case. So if you see example for that, let's assume you continuous deploys your software. So every day we create a new software version and we deploy it automatically to a production system. So let's say we have solved the problem with JBehave, or we just skipped the explorative testing. So we deploy on the production system, and we want to release a specific feature on a specific date. So that's also a problem that you try to solve with continuous delivery. You don't want to put all the features you created just today on your production system. So you might have some kind of marketing campaign starting next week. So actually you want to release your feature next week. And to achieve this, it's quite easy to create things like a feature toggle. So for example, a feature toggle could be a configuration in your database, it could be a configuration in a property file, or it could be a simple if statement in your code. So it actually disables your feature that you actually created and gives you control about when this feature is actually active in your production environment. So let's say you commit your code and you deploy your code to a production system, and sometimes later you have some kind of acceptance test that is testing this feature on a staging environment, for example, and it's getting accepted. So you get a go for releasing this feature actually. Then sometimes in the future you decide when is the right moment to release your feature, and then you just have to configure your software or release a new configuration for your software, and this new feature is actually released to production systems. So feature toggle actually is a quite good mechanism to use continuous delivery, but also keep control of when your features actually are going live. So integrating continuous deployment with sprints. This is something I also always hear when talking with people, like how can we integrate continuous delivery and continuous deployment with our sprints. We work with Scrum, and we have some kind of, let's say, 2-week sprints, and we actually want to release features at the end of the sprint. So it's the same again. We have some kind of start of the sprint, so we work on this sprint and we deploy our versions continuously. Bugs, for example, must not wait until end of the sprint. So we fixed a very important bug, we can release it immediately. We don't have to wait until the end of the sprint. So those things could be released immediately. If we have some kind of feature that should be released just at the end of the sprint, we could use feature toggles, for example. And if the sprint ends, it does not matter. We just continuous delivery our software. We continuously deploy our software. And if the end of the sprint should actually release a new feature, we just release a new version with the feature toggle, and that's it. So you can easily integrate continuous deployment with your sprint and with Scrum and Kanban styles. It's more or less an organizational topic and not a technical topic, but actually continuous deployment focus a lot of organizational stuff, and this is one of those. So you can actually very easy integrate continuous deployment and continuous delivery to your sprints. But actually now we know something about how to do it organizational, the deployments. We have an idea how we can work with feature toggles, but the real deployment should be hopefully zero downtime. Imagine if you have, for example, 5 persons and everyone is working on features, so you have probably about 10 or 15 deployments each day. So you don't want to have the platform or your production system to be offline at every deployment. So there are different strategies how you can achieve to deploy your software without downtimes. And one of those is, for example, a blue-green deployment. So if you imagine we have a scenario like that, we have the internet and the kind of load balancer who balances our load between 2 instances of our application with a single database behind it. We actually can remove one of those instances from the load balancer and deploy the new version on it. And afterwards, we deploy the other instance of the application, put the new version on it, and afterwards we have a new version on both instances and we're up and running again. So that's a quite simple mechanism. It's called blue-green deployment. You have to think of a lot of stuff when you're doing things like that, because if you change the schema, for example, of the database, you have to be some kind of you have to support deprecated software versions, because you just cannot skip all the stuff and drop some tables and drop some columns, and while the older version of your software is still running. So you might get some problems with that. So there are a lot of things you have to think about, technical things. There are a lot of tools helping you with those things. Unfortunately, I don't have the time to name all those, but one of those, for example, is Flyway. It's kind of migration framework which can help you to migrate your schemas of databases on the fly when you boot up your application. And there are a lot of other frameworks out there, like web server, like NGINX, for example, who has inherited a load balancer, inclusive load balancer, who can do things like that, reloading load balancer configuration on the fly, because a lot of load balancers, for example, losing requests when they reload their configuration. So it's also a very technical topic that you want to have, your load balancer reconfigured on the fly without losing requests, that you have a real zero downtime deployment, not an almost zero downtime deployment. And there is a lot of things you have to think about it if you want to do a blue-green deployment. There is another way. Some companies are actually practicing a so-called canary release or canary deployment. It's the same situation like before. We have a load balancer and two instances of our application, and with a single database. So canary release does the following: it deploys a new version of your software on one instance, and keep it alive with the old version of your application. So now you have two different versions in your production system, and the new version gets partly a little bit traffic. So like 10% or 5% of all the traffic is delivered to the new version, and your business guys can evaluate if the new version fits their requirements, if it's good enough, if the people are responding to new features, something like that. And if you're happy with the new version, you can do the same on the other instance. So you can deploy the other version on the other instance, and afterwards you have the new version on both instances again. This is extremely dangerous, because having more than one version in your production system is a pain in the ass. Sorry for that word, but it's if you imagine if you have more than one instance, for example, if you have 10 instances or 20 instances of your application, and you have a continuous deployment mechanism, you might have more than one and more than two versions out there. So you might have 3 or 4 versions of your application in production system. So it's the nightmare of every operator. So to avoid this, actually, the best approach is actually to do some kind of blue-green deployment. The practice shows that it's more convenient than to have more than one version out there in your production system. Now, if you imagine you have released a new version, automatically there might be a problem with this version. So you deploy version 1.1, and then you see there is a bug in this version, and this bug, you want to fix it. So the deployment of 1.1 is quite young. You just did it right now, and you see the bug. So you either can roll back your software version, so you can go back a step and deploy again version 1.0, because you know that this version is working and you're happy with it. But this brings also a lot of problems. If you imagine if you do some kind of database migration, so you migrate your database to a new version, you drop some columns, you add some new columns, you do some indices. So rolling back all of those changes is extremely expensive. So those people who are practicing continuous deployment very long already, they also move to another strategy, like continuous delivery with forward-only deployment. That means if you find a bug that is actually has to be fixed right now, just don't go back to another version that already worked, but go forward to a new version. So fix this bug and release a new version of your software. If you do so, you get rid of a lot of problems, like stepping back could always be very expensive. There are a lot of scenarios where this might not work that easily, and the rollback of your software is actually more expensive than creating a new version. So creating a new version normally is less effort and more convenient. So if you if you hold down on forward-only deployments, you might have some stress. Like if the bug is now reported, you have to fix it immediately and release it immediately. So it's a little bit stressy for development, but in the end, it's a lot of effort that you can get rid of instead of rolling back. But I work already with continuous delivery for, I don't know, 1.5 years already, and there's always the same topic when I talk with people, the quality assurance, because quality assurance could also be a dragon sometimes. So they spit some fire and they have a lot of arguments against continuous delivery and against continuous deployment. And you hear a lot of stories when talking with quality assurance. So they are quite eager to find bugs. They are quite eager to test your software and actually to show you the bugs. I find the bug, you cannot deploy. So things like that. They're quite happy if they find something. And it's always a struggle, talking with the quality assurance to get those, get an agreement from the quality assurance to use continuous delivery and to use continuous deployment, because they're a little bit afraid of deploying new software automatically to a production system without having it manually tested. So the best approach for getting rid of all the struggle with the quality assurance and all those discussions is actually to integrate the quality assurance into your process. So try really to find a way where you can integrate the quality assurance to your process, like using behavior-driven development. That's for example an approach where your quality assurance can define acceptance criteria that are automatically tested, for example with JBehave. Or they can create acceptance criteria along with a story. So if you define a story for your sprint, just ask the QA to create some kind of sheet and define which are actually the acceptance criteria that this story is done. You also have, it's not here, but you also should have some kind of definition of done. It's very important. So to know when your user story is actually done. So it also includes having automated tests, having a QA look on it, might also have some other developer to review your code. So definition of done also helps to improve quality of continuous delivery. And then you have to define a regression test, for example, and support the automation. That is something that quality assurance can help you a lot with. So they know already about all the regression tests, all the automation tests, so they can help you to automate those things. And if you have the skilled people, they actually also can help you writing test automation. So we have a lot of skilled quality assurance guys who also write Selenium tests, for example, for their own. And there is a nice tool out there for Firefox, for example, which can record things and then replay those things with Selenium. And that's a cool tool for quality assurance to speed up things. So to do not always the same thing, but you can save those things, like, I don't know, logging in and checking your user profile, logging out, something like that. You can automate this with a simple browser plugin, actually. So if you use things like that, you can automate things and your quality assurance is quite happy. And if the quality assurance actually can work together with you in the complete process, like defining acceptance criteria, might also create automated tests. So if you integrated those guys into your process, you get quite good and quite positive emotions out of them. Like they're quite happy with it, and they're on your side actually. And this is the main goal. So don't fight against the quality assurance guys, but try to hold it, to get it on your side, to help you actually create a really cool software, a highly tested software with a lot of test automation. So if you want to use continuous delivery or continuous deployment in your company and in your project, there are some kind of recipe how you can do this. For example, in the first step, you should identify some optimization potential. So if you think on your deployment process, how you do it nowadays, just find something that you can somehow optimize. It could be done faster, it could be done simpler. So find some way to make it easier, to make the most out of it. Or you might find something that you can automate actually. So if you found something, optimize it or automate it and measure the improvement. So did you save a lot of time? Did you get faster? Is it more convenient, more usable, the test suite, something like that? Try to find a measurement to see if this already improved some kind of steps in your continuous delivery pipeline. And if you did this, gather know-how. So it's very important to get some knowledge, to get used to it. And for example, if you automate your acceptance tests, get used to it. See that every developer knows how to write acceptance tests in an automatically way. So if you think on all those things, and well, it's always a step-by-step integration. So you cannot use continuous delivery right out of the box, or you cannot integrate it very easily in your company. There is a lot of things you have to talk about with your guys in a project. There are not just organizational stuff, but a lot of technical stuff. And my experience tells me that the technical stuff could always be solved somehow, but there is no single recipe that works on every project. Every project is different. Every project has their pains, and so I cannot give you some guideline how you can integrate continuous delivery in your project, because there are so many different technical approaches. So this is a thing that you have to solve in each project for themselves, but the organizational stuff is more or less always the same. You have to actually prepare yourself and prepare your team to use continuous delivery and deployment in your project, because that means actually in the end that if a single developer creates code, this code actually is deployed into production systems, maybe on the next day, maybe on the same day. So every code that you write right now is deployed on production systems. And this is quite different to not using continuous delivery, because in this scenario you often have people that write code and say, oh, let's get tested later, so I don't care if the code is fine or not fine. They test it and they find the bugs if I wrote some bugs. So you have to get rid of those mindsets and try to find a mindset where you really get aware of code quality. And there are a lot of things you can think about, like code reviews, like automated code quality reports with SonarQube. There are a lot of tools that help you, but this mindset is the most important thing on continuous delivery and continuous deployment. Getting the mindset ready for your developers and, of course, for the quality assurance. So in the end, continuous delivery is about ease your releases with every necessary step, and create idempotent builds and environments. So don't struggle around with things like that works on my machine but not on the other machine. So those things you have to get rid of. You have to automate those things and focus really on the fastest way of releasing a software version. Of course, automation means many repeats, and if you do something more often, you get used to it, you reduce your errors, you reduce your failures, you get better in doing things if you do it often. And integrate the quality assurance in all of your processes, starting with creating stories, user stories, and with acceptance tests for those user stories, and apply continuous delivery step by step. It's nothing that you can do overnight. It's nothing that you can do until the end of the week. It's a step-by-step way that you have to go and take everyone in your project with you and create those mindset that everyone is talking about the same. And actually everyone knows that creating code today, it means it's getting released in production systems. So be aware of code quality. And talk about your pains. And of course, talk about your success, because continuous delivery and continuous deployment are just terms. They're just trendy right now. Everybody want to use it. Everybody tries to use it. Some people fail in special conditions and in special situations. So talk about those things that people can learn from it. So I would suggest, if you use Twitter, just Twitter it on continuous delivery tag, so that people just get in touch with each other, and there might be people out there already had the same problem like you had, in an organizational way or in a technical way. So there's a lot of information that I talked today about, and a lot of stuff that we could talk on and on. This is a never-ending story, and I hope I could put it together somehow in a short 54 a 45 minutes talk. So if you have any questions or if you have any concerns or something to ask, now would be the right situation.
Hi. I just wanted to ask about the feature toggles.
Yeah.
And is it a kind of property that you can set also on runtime, that you enable or disable a property, a feature? Or is it that you have a feature toggle also at the build, so that the source code is not builded and
Well,
delivered to the system?
that's a good point. Actually, every change of your set of features should actually be versioned and documented. So the best approach would be to put it in your subversion or in your Git to really document the change, that you can actually review those changes. Because if you release the feature today and the next week you want to have a look why this feature is actually enabled, you don't find the right moment when it was enabled. If you have some kind of on-the-fly configuration in your database, try to create some history logs or something when this configuration is changed, because you might need this information sometime in the future. Any other question? All right, so I just can ask you, try it out, try to optimize your continuous delivery build and try to create a continuous delivery pipeline, or start with creating development environments on all your machines of your developers. This is the first step, and I think this is quite important in future. And if you have any questions, I'm around here today and tomorrow, so I would be happy if you just find me and talk about some continuous delivery stuff. Thank you very much.